Hello, Algebra 2. Today we are going to continue our graphing of sinusoidal functions. Remember, sinusoidal is just a really fancy word that refers to graphs of sine and cosine, transformations of those graphs. They will give you periodic functions that occur in waves. And over the past couple of days, we have looked at different transformations of sine and cosine. We've changed the amplitude, we've changed the period length, we've shifted those graphs vertically and horizontally. And so what we're going to do today is combine those transformations. What happens when more than one change occurs to our parent function? So I'm looking here at a page of notes, and you can print this off if you like. This equation, y equals a sine of b parentheses x minus c plus d, that represents your general equation for sine. And you could replace sine with cosine and have your general form for cosine. And there is a role that A, B, C, and D play. They change the graph in a specific way. So this set of notes here is just a graphic organizer, and you'll notice that there are 4 pieces, and you can see some changes in the graph for each of those from the parent function, what is changing in each one. So I would just suggest pausing the video here and seeing if you can identify, is it A, B, C, or D that is being changed in each of these 4 examples? What is happening, what is changing, and what variable would make that change? So go ahead and press pause and see if you can identify that. And then you can begin the video again, and we'll see if you got it right. Okay, so I'm hoping you paused and identified each of those 4. I like to start looking at changes. I like this last piece, D, first, because it's outside of the sine or cosine function. And that adding at the end, that is your vertical shift. That is going to move the graph up and down. So I can see down here in this lower right-hand corner, these graphs are being shifted up and down. So this value is that D. That is what is going to create the vertical shift. And just a reminder, in a vertical shift, if you're adding something, that means up. And if you subtract, that means down. Remember, that's a rule that is true for all functions. Okay, so if I think about that shifting, I then like to think about my horizontal shifting. That would be that C value inside the parentheses, inside the function. When you change the input, that is going to shift that graph left and right. So which of these 3 that are left is moving that graph left or right? That's going to be down here in the lower left side. So this would be C is going to change that. That is our horizontal shift. And remember that opposite effect occurs. So if you're adding something, that means left, move left. And if you're subtracting something, that means right. So we've got our vertical and horizontal shifting, and we've taken care of C and D. So we only have 2 left. We have to figure out what does A do and what does B do. A, remember, is that amplitude. That is that vertical stretching. So which one of those is stretching the graph, making it taller? That's going to be upper right. This is A. That is, remember, the absolute value of A is the amplitude. This is your vertical stretch. And remember that amplitude is always going to be positive, even though that A value could be negative. Remember, if A is negative, you're going to start at the opposite value. For if it's a sine, that means you'll be going down first. And if it's a cosine, if A is negative, you would start at a minimum rather than a maximum. So this is your vertical stretch. Remember, you can also find your amplitude by taking the maximum minus the minimum and dividing by 2. And it is the stretch above and below the horizontal axis. All right, that leaves just one left. That would be B. Remember, B is going to change the period length, how long it takes to complete one cycle. And so B is going to change. It is going to be a horizontal stretch or shrink. Okay, so it's going to do that horizontally. Now remember that B doesn't tell you the period length. We have to do a little calculation to figure out the period length. But B is the number of cycles in 2 pi radians. And to find the period length, we're going to take 2 pi divided by B. This is going to be essential. We have to do that little bit of calculation first. So that's a nice summary sheet of all of those transformations. And we're going to begin to look at equations where multiple things occur at the same time. I won't always give you all 4 transformations. It might be some smaller combination, but we want to think of them individually as we put them together. All right, so now I have an example I would like for us to work through. I'm going to move to my whiteboard. You might just want to turn this page over. You could create that. Let's see. I would like to look at this equation here. Y equals 2 cosine of 1/2 times the quantity x minus pi plus 3. All right, now notice I've actually picked a value for A, B, C, and D. And so I want us to look at a really thorough example with all of the changes, and then you'll get a chance to practice in your homework. Okay, so as I look at this, you can move from left to right. You can do these in any order that you like. I tend to like to set up my graph with the shifting in mind, because the shifting is going to change where that graph is. So notice that I am shifting up 3. I'm just going to write like this means up 3. Okay. And this means, maybe I'll just go to the right pi. I should probably go up 3 to the right pi. This is my amplitude. And then for the period, I need to do a little calculation. So the period will be 2 pi divided by 1/2. And remember that is like multiplying by the reciprocal. So the period length will be 4 pi. Now there are 4 things I'm going to ask you always. I'm going to ask you to tell me the amplitude, the period length, the domain, I'll do a capital D, the domain, and the range. Those are the 4 things I'm going to ask you each time. So I can see from my equation the A value, the amplitude's going to be 2. The period length is going to be 4 pi. The domain is always all real numbers. Now the range you might be able to predict right now, or you might want to wait till your graph is done to fill in the range. So if I go to graph this, I want at least 2 cycles. And so I would like to put my shifting on first. And I'm already seeing that I probably should not have drawn that horizontal axis where I did, because look at this, I'm going to be shifting up 3. That is going to be my new midline, up 3, and then I have to stretch up 2. So I have to stretch up to 5. So I think I'm going to redraw this. That looks a little bit better. Because I have to get all the way up to 5. And my midline is at 3. So I want to put a dotted line at 3 because I'm shifting up 3. So that dotted line is going to be up 3. It's important that you put that dotted line in because all of the zeros are going to be on that new horizontal axis. And I have to shift up 2 because the amplitude's 2 from that midline. And then I will shift down 2. So I'm going to bounce between 1 and 5. Now that I've actually created my vertical axis, I can fill in my range. 1 is going to be the minimum, and 5 is going to be the maximum. So I'm going to go between 1 and 5 with the or equals to. We say that's inclusive. All right. Now I'm going to scale my horizontal axis. This is based off of the period length, that 4 pi. So I'm going to mark 4 pi, and I have to label it. Whatever the period length is, gets that first label, and then I divide it into the quarter points. Okay, and I can see if this is 4 pi, this must be 1 pi, 2 pi, 3 pi, 4 pi. You do not have to label all of those. It's helpful to label the middle one. That is 1 cycle. Now I'm going to extend that another set of quarter points to 8 pi. So the one in the middle would be 6 pi. So now my horizontal axis is labeled based off of what this period length is. This is a completely, well, not quite completely, but the axes are completely labeled. I've forgotten one thing, and that is that horizontal shifting. I need to go pi to the right because it was subtracting. So hopefully, and actually in all the examples I give you, once you completely label that horizontal axis, your horizontal shifting should appear on there. Now that doesn't always occur. In pre-calculus and higher level math, you're going to see different amounts of shifting. But with the examples I want you to do by hand, you're going to be able to see it if you've labeled them correctly. Here is pi right there. So I want to do a vertical dotted line. I do want to see the dotted lines. It tells me that you know where that shifting is moving the graph. All right. Now we've got it completely set up. So it's as if the intersection of those two dotted lines is my new origin. This is really where I'm starting. Now, we're going to go up to a maximum of 5 if you want to do a dotted line at 5 to remind yourself not to go above there, and a dotted line at 1 to remind yourself that that's the minimum. Our graph is going to bounce between there. Now, look at your sine or cosine curve. Which one is it? It's cosine. Does cosine begin at a minimum, maximum, or 0? Well, it begins at a maximum. Now, do check this a value. If the a value were negative, it would begin at a minimum. But it's positive, so we're beginning at a maximum. That means right here at the intersection of those two shifting lines, I need to begin at a maximum. That means I'm going to begin up here at 5. That's the maximum. And now every quarter point is where I put those minimums, maximums, or zeros. And so I'm going to bounce through the quarter points. And if I've shifted to the left or right, I do want to make it back to that original y-axis. So here would be a 0, and I could come back here as well too if I wanted. And then I connect those. And this is the transformation of cosine into y equals 2 cosine 1/2 of the quantity x minus pi plus 3. It's a rather intimidating equation, but if you break it down into its 4 changes, I think you'll be able to handle it pretty well. I have 6 examples for you to try in the homework. So take them piece by piece. Make sure that you're writing down the amplitude, period, domain, and range, and that you're showing me those dotted lines on your graph, and label those axes carefully. I know you can do it. I hope you enjoy it. Let me know if you have any questions. I'd love to help. Thank you.